With this video, class 10, we are going to start the topic refraction of light, which of course you already are familiar with. Okay, so let us very quickly go through its definition. The phenomenon of bending of light when it moves from one transparent medium to another is called refraction of light. So we already know whenever light travels from one transparent medium to another, okay, what happens is the ray of light bends. Okay, that is, it changes its direction of movement. All right, and this phenomenon in which the ray of light actually bends from its path, okay, when it moves from one transparent medium to another, of course, is what is called refraction of light. Like, for example, let us look at a ray of light moving from a rarer medium to a denser medium. Okay, so this ray of light is coming from a rarer medium. So XOY over here is the surface of separation between the two media. Okay, so this ray of light is actually moving along the dotted lines. So what happens is the moment it enters the denser medium, it bends from its path. Okay, and how does it bend? It bends in such a way that it moves closer to the normal, or we say it bends towards the normal. So remember, whenever a ray of light travels from rarer to denser medium, what happens is it bends away towards it bends towards the normal. Okay, this phenomenon of bending of light is what is called refraction of light. Okay, we have another case where the ray of light is bending away from the normal, and this happens when ray of light comes from a denser medium to a rarer medium. Okay, so this ray of light is actually moving along the dashed lines. Okay, so what happens is when it moves from denser to rarer medium, it moves away from the normal. Okay, so here XOY is the surface of separation between the two transparent media. NOM is the normal. NOM is the normal, remember. Why is it called normal? Normal means perpendicular. It's a mathematical term. It's called normal because this NOM is perpendicular to the surface of separation XOY. That is why it's called the normal. Don't forget. AO is called the incident ray. This AO is called the incident ray. OB is the refracted ray. Angle AON meaning AON, that is the angle which the incident ray makes with the normal is called the angle of incidence, denoted by angle I. And likewise angle BOM or MOB. Okay, this angle is denoted by angle R, and this is called the angle of refraction. With this video, I have attached two small videos showing you the phenomenon of refraction of light. One video in which a pencil appears bent when it is placed in water, and the other one in which a coin appears to be raised up a bit. Okay. In this video, you can see that the left coin looks a tad bigger and closer than the coin to the right. Here I have used the same two glasses, the left one being filled with water, the right one is empty. Okay, only the 10 rupees coin is there. Okay, and of course, yeah, I have used the same two coins. So you can see the left coin looks a tad bigger and a bit closer than the coin to the right. This of course is because of refraction of light. You can also see that the glass to the right looks more deep than the glass to the left. To give you other examples of refraction also, binoculars and telescopes works on the principle of refraction of light. Okay, the very fact that we see objects closer using a binocular or telescope, okay, or for that matter a microscope, okay, is because of refraction of light. We see rainbow happening. Okay, we see rainbows. Rainbows are also formed because of refraction of light. Okay, when we are close to a swimming pool, say for example, the bottom of the swimming pool appears to be raised up. Okay, it appears to be less deep than it actually is. All right, that is also because of refraction of light. And to give you another example, in the desert, people see something called a mirage. Okay, so the phenomenon of mirage that people see in the desert is also because of refraction of light, remember. Now let us see what happens at normal incidence. That is when the ray of light moves from one transparent medium to another, be it rarer or be it rarer to denser or from denser to rarer, does not matter. It could be either of the two scenarios. Okay, so whenever a ray of light moves from one transparent medium to another along the normal, what happens is, this is a special case, the ray of light moves undeviated. That is, the angle of incidence, when the angle of incidence is 0 degrees, the angle of refraction is also 0 degrees, remember. All right, so this is one case when the phenomenon of bending does not take place. Okay, this is for normal incidence, remember. Now let us look at the laws of refraction. So law number 1 says the incident ray, the refracted ray, and the normal all lie on the same plane at the point of incidence. Okay, we can check this. So here, this is the picture. So the incident ray, the refracted ray, and the normal, NOM, they all lie on the same plane, that is on the plane of the paper right now, you can see. Okay, so all of them lie on the plane of the paper at the point of incidence. O is the point of incidence, of course. So at the point of incidence, all three, the incident ray, the normal, and the refracted ray, they all lie on the same plane. So that is what your law number 1 says. Then law number 2, this is also called Snell's law, S-N-E-L-L-S, Snell's law. So it says the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant for the pair of media concerned. So up to here actually is the Snell's law. Then after this constant, so we are defining what the constant is. This constant is called the refractive index, denoted by a mu, Greek letter mu, refractive index of the second medium with respect to the first. Okay, so this constant is what is called the refractive index of the second medium with respect to the first. All right, so this is more of a mathematical statement. Snell's law is more of a mathematical statement. So it says the refractive index of the second medium to the first is equal to the ratio of the sine of angle of incidence, of course in the first medium, the angle of incidence is in the first medium, to the sine of angle of refraction in the second medium. Okay, so, and remember, refractive index, since it's a ratio of the same two quantities, in fact sine of any angle itself is a ratio of two lengths. Sine is what? Is the ratio of perpendicular and hypotenuse, so don't forget. Okay, so since sine itself is a ratio of two lengths, so therefore sine I is unitless, sine R is unitless, so thereby refractive index itself has no unit. By the way, we need to remember one thing, that is whenever refraction takes place, okay, at the boundary separating the two media or in between two transparent media, what happens is refraction is always accompanied by reflection. Okay, so whenever a ray of light moves from one medium to another, since it is bending towards the normal here, this has to be a case of light moving from rarer to denser medium, of course. Okay, so whenever refraction happens, remember, always partial reflection takes place. Okay, of course obeying the laws of reflection, remember.